Good day everyone. I'm Abdusy Sharif from National University Jakarta, Indonesia. Today I'm going to present our paper entitled Performance Analysis of RPL Protocols in LLN Network using Friedman test. In addition, this work was part of a collaboration with CC Engineering School and University of Haute-Alsace, France. As an introduction, maybe we have already know a bit or more about smart cities and Internet of Things. However, these technologies rely on various networking protocols, right? Without protocol, it won't work. The routing protocol for low power and lossy network, or RPL, released about 8 years ago as an RFC 6550, while RPL constructing the path from source to destination. RPL uses a single metric called ETX, where ETX describes the expected number of transmissions required to successfully transmit and acknowledge a packet on a wireless link. And RPL will look at the neighbor statistic model, and then ETX is calculated based on the packet delivery of forward and reverse direction. However, this scheme of RPL might arise problems such as the nodes in the network could lead to high latency, and then the battery is exhausted. According to a survey paper, since RPL was launched in 2012, more than 90 RPL variants are published in order to improve RPL. In our previous work, we proposed RPL OC, which is an extension of RPL based on the operator calculus approach. It provides an end-to-end optimal path by taking into account multi-metrics such as ETX, latency, energy, and RSSI. In this research, we have conducted some simulation and performance analysis between RPL OC, RPL standard, OFFL, and co-RPL. However, adapting simulation to compare several protocols may be enough when the differences are very clear. But in our case, a direct comparison may be not enough to draw sound conclusion. That is why here in our research, the statistical assessment is needed, and we are going to use Friedman test. The objective of this research are first to validate the null hypothesis, and the second one is to determine enrichments across multiple group measures. Okay, let's jump to our proposed protocol. Here we will provide a short review of our previous work, which is already accepted. RPLOC, based on the operator calculus, we call this RPLOC. As I said in the introduction, RPLOC uses multimetrics like energy, RSSI, delay, and ETX. So we prefer to find the end-to-end paths respecting to constraints. For instance, we prefer a path with maximum energy, maximum RSSI, but with minimum delay and minimum ETX. However, this is a multi-constraint path problem, and operator calculus can discover all feasible multi-constraint paths between a source and a destination with the minimum hop count. It means that the operator calculus can provide the best, or in other words, optimal paths from the global view of the network in end-to-end manner. Okay, let's see this example. We have a 6-node multi-weighted graph as follows, where its edge is appointed a vector of positive weight. The task is to find all feasible optimum paths from node 1 to node 5. As you can see here, we have multi-option, multi-paths to reach the node 5 from node 1. And the constraint we have in here is 30, 25, 30 and 35. And in particular way, the operator calculus will construct the nilpotent adjacency matrix as follows. And finally, the operator calculus will provide the feasible paths that satisfying the constraint as follow. Before we perform the simulation, we have contacted the authors of Co-RPL and OFFL, and we asked them gently to share the source code for comparison purpose. And we have performed 3 scenarios. In the first scenario, since the operator calculus approach provide feasible paths from source to the destination, and we realize simulations by performing RPLOC with other related protocols, and we varied the data rate from 1 packet per minute to 60 packets per minute. And we also conduct some simulations where some nodes drop one by one in order to see the performance of the protocols. In terms of quality of services measurement, we focus on performance indicators as follow: packet delivery ratio, throughput, end-to-end delay, energy consumption, and duty cycle. Okay, we jump to statistical tests. Okay, in this section we are dealing with the application of statistical tests for the the formal comparison of several algorithms in order to determine whether one generally outperforms the others or not. However, one of the purpose of statistical tests is to predict which of the possible hypotheses will be considered. H1 is a subject that being proved, and the whole testing process is done by seeing this hypothesis as true. If the test leads to the rejection of H0, then we believe that H1 is probable rather than H0. The conclusion is derived from the sample result following the decision rules. We make a decision only by achieving that there is some risk that it is incorrect. Okay, let's talk about the Friedman test. As maybe you have already know, the Friedman test is a non-parametric statistical test to evaluate the difference between several related samples. Friedman test can be used also to prove the null hypothesis that the multiple sample measures have the same variance to a certain required level of significance. To compare the performance of protocols in our research, we compare 4 protocols which RPLOC, RPL standard, OFFL, and co-RPL. We perform the Friedman test to analyze the average result of several simulations. First, we ranking the results of each protocol which is required for each sample being studied, and then we giving the rank. For example, 1 to the best and K to the worst, as you can see in this table. Then we calculate the total sum of squared ranks and its relationship based on the number of samples examined. Next, we calculate the statistical test, and then by using the table F distribution as degrees of freedom, we found that the statistical test is higher than F distribution, which means that we reject the null hypothesis, and there is at least one algorithm whose performance is different from at least one of the other algorithms studied. However, it is necessary to perform paired comparisons to know which algorithm is really different. And to do so, we perform the bilateral test by calculating the absolute difference of the summation of algorithms ranks, as you can see in this table. For example, we want to compare two protocols, A and B, for example, or RPL OC with RPL standard. For example, we can say that these two protocols are different if the absolute summation of rank A minus B is greater than the critical value, and the result reveals that the value of RPLOC is greater than the critical value. In addition, it can be seen that the result obtained by RPLOC are different from those obtained by RPL standard, OFFL, and co-RPL. As conclusion, we have presented a statistical analysis of 4 RPL variants by using Friedman test, and we found that the test statistic value of absolute difference summation of protocols ranks is larger than the critical value, which means that we reject the null hypothesis, and there is strong evidence that the protocols are different. In addition, from this evaluation, we can say that the proposed RPLOC is superior and outperforms other protocols, in this case RPL standard, OFFL, and co-RPL. Thank you for your attention. Thank you. Goodbye.